Okay, we are going to take a look now at solving inequalities that involve absolute value. And I labeled this compound inequalities, even though they're not technically compound inequalities in the sense that there's two written at once. But because it is absolute value, we have that whole situation to deal with that we'll talk about in a moment, where you're solving for more than one case when you're doing that because of what absolute value is. So I think it's important to take a quick look at, if you remember, when we were solving absolute value equations, and let's just write a quick example. So supposing you have something like x plus 7 is the absolute value of x plus 7 is equal to 11. Right? So if you have a situation like that, where you're solving that, if you remember, the answer to this, right, is affected by these absolute value brackets. So what it means is there's two possible cases that you can have. You can have one case where the information inside here is positive already, and then the absolute value brackets don't really need to do anything. And then you have another case where the information in here is negative, and then because it's inside the absolute value brackets, they make it positive. Because remember, absolute value is all about distance, and distance is positive. So, so what we're going to do is, if you remember how we did these, is, your first case would be x plus 7 is equal to 11, and you would solve that in your traditional way. You get x is equal to 4. So that would be your first case. But your second case, which is the negative case, right? You would take what's in there and make negative, and then you have to distribute that negative sign throughout the left side there. And you add 7 to both sides, you get 18, but that's negative x, which means that x is negative 18, because we would multiply this whole thing by negative 1, right? We would go negative 1 times both sides and get that. So solving inequalities is very much the same. The only difference is, instead of equals, you have your inequality signs, and we have to keep in mind the rules we got to follow when we're multiplying or dividing by a negative number. So let's take a look at a couple examples for this first video. So this first one here, we got absolute value of m plus 2 is less than 11. Okay, so we're gonna look at case 1. All right, and case 1 is going to be positive. All right, I'm going to be really total Captain Obvious with this for these first couple. So m plus 2 is less than 11, and then case 2 is going to be our negative case. All right, and that's where you're going to take everything that's in there and we're going to make it negative. We're going to go m plus 2. That quantity is negated, and that's also less than 11. So let's solve case 1 first. We'll subtract 2 from both sides. We'll get m is less than 9. Then over here, if you remember how we distribute those negative signs, it's the same as multiplying by negative 1. So you get negative m, and then it changes the sign basically of everything in there, and it becomes negative 2. Less than 11, we'll add 2. All right, and then that gives us negative m is less than 13, and then we're going to multiply this whole works by negative 1, right? And when we do that, this is where it's different, is that sign changes, right? So now we are left with m is greater than negative 13. And so for solving this, right, and if I remember, we'll make this 0 and go up by 2's and down by 2's as well. And so when we write the solution set, this is where it closely resembles compound inequalities, because with absolute value solutions, when you graph them, sometimes you'll get an intersection and sometimes you'll get a union. It just really kind of depends on how the answers shake out. So here you've got m is less than 9. So we're going to go to where 9 would be, and 9 would be about right here. You circle it, and let's just leave it for now. Normally we know we would have a arrow going that way, right? And we'll just put that little crooked arrow there to remind us. We got m is greater than negative 13 here, so we're going to go over to about where negative 13 is. We're going to put another mark, and that's going this way. So the thing is, all the solutions for this lie within and between these two kind of endpoints here. So this problem right here, the solution of it winds up looking an awful lot like an intersection, which, if you remember, is an and statement, right? So we get all this. So all these values in here should be solutions for this right here. So as I like to do, let's put in 0 because it's part of the solution set and see if it works out. So 0 plus 2 is 2, so the absolute value of 2 should be less than 11, which it is, right? Because it just becomes 2, and 2 is less than 11. So any of these numbers in here, if you put them in there, are going to work out for this. All right, so this is kind of the basic idea of how these work. What I'll do is we'll have a couple more videos of just some more examples to show you. Okay?